So in the previous class, we have completed reaction with acid and alkalis, right?
Yes.
So, do you have any doubt regarding this topic?
No.
Okay. Okay, we had completed S block. So write a point with me. We have completed basically amphoteric. These all are amphoteric metals. Write a note. Boron does not.
Can you scroll a bit up?
What you just said?
Can you scroll up a little bit?
Yes, why not? Is it enough or should I scroll?
Yes. And
So
done.
okay. Boron does not react with acid and base even at moderate temperature. Where when we talk about aluminum, aluminum react with acid as well as base. With acid, it gives a reaction, shows a reaction. Just write it. Oh, wait.
Done. Done.
Okay. Now I'm going to write equation of aluminum with acid as well as base. Aluminum react with acid. Since it is metal, metal reacts with acid to give salt plus hydrogen gas. Salt plus hydrogen gas. So you can balance it with this. And aluminum also react with base to give sodium aluminate plus 2H2 hydrogen gas. And if you react aluminum with base in presence of water, and water should be more, it will make a complex compound. Coordination compound, we also call it as coordination compound. 3H2 gas will be released. Just write it. And there is a chapter in class 12th which is known as coordination compound, and this compound is also known as coordination compound. Just write it and let me know if you are finished with this. After this chapter, how many chapters will be left?
2 chapters.
4 chapters.
2.
2. One is thermodynamics and another is
Equilibrium.
okay. There must be an extra class, and your final paper will be from mid March.
Yes.
Okay. Just write it and let me know if you are finished with this.
Done.
So I'm going to write gallium, about gallium. Gallium metal reacts with acid. Indium, it is also metal, reacts with acid. In the same way, thallium is also metal, reacts with acid. Just write it. Only boron does not react with acid as well as base.
Done.
Very good. Now we will talk about halide of group 13. Halide of group 13. When we talk about halide of group 13, there are two halides. One is basically trihalide and another is monohalide. And in monohalide, only TLX is possible. Except this, no elements from group 13 forms monohalide except TLX3. And I already told you that this is not TLX3, basically TLI3. This is TLI3, and in the previous lecture we have studied as I3 minus and TL plus, because thallium is stable in +1 oxidation state and highly unstable in +3 oxidation state. And in TLI3 there is bond between iodine and thallium as ionic bond. TL plus, it will exist in +1 state, and I3 minus, and so there will be attraction between positive and negative charge, so it is ionic bond. When we talk about trihalide, basically it forms EX3. And when we say E, that means boron, aluminum, gallium, and indium. Just write it. I'm going to write some points regarding TL. TlCl3 is unstable, but TlCl is stable. Why? Because thallium is stable in +1 oxidation state. Because in thallium, the stability of +1 oxidation state, OS stand for oxidation state, is higher than +3 oxidation state due to inert pair effect. Due to inert pair effect. Let me know if you are done with this.
Done.
Now, tell me how many electrons, which one is central atom, boron or chlorine? Can you tell me?
Boron.
Boron. How many electrons does boron have after bonding? How many electrons does boron have? 6 electrons, because one bond is made by 2 electrons. So since boron is forming 3 bonds, that's why it will have 6 electron. Is that clear?
Yes.
Boron has 6 electrons. And how many electrons should a central atom should have? How many electrons a central atom should have? To be stable, how many electrons should have? A central atom should have how many electrons?
8.
8 electrons. That means trihalide, if you are going to write another halides of group 13 like AlCl3, uh, GaCl3, all these compounds are electron deficient. Trihalide of group 13 are electron deficient, right?
Yes.
Electron deficient. So in order to get a stability, there will be there will be some bonding that is known as back bonding and dimerization. So write with me. Trihalide of group 13 are electron deficient compound, and we can say it is Lewis acid, or it is Lewis acidic in nature. Basically, acid, according to Lewis, acid is the substance or molecules which gain electron, and base is a substance which donates electron. The one which who will donate electron, that means they will have the molecules or the substance which donate electron. The substance will have more electron or electron rich species. Are you getting my point? If
Yes.
someone is donating electron, that means that someone will have some extra electron. And if a molecules is gaining electron, that means that molecules required electron. So whenever a substance or molecules or compound or a species gaining electron or withdrawing electron, that substance is known as acid, and the substance which is giving or donating lone pair electron, that is known as base. So since trihalide of group 13 are electron deficient compound, so it will attract or it will withdraw some electron from other molecules. That's why these are acidic in nature. Is that clear?
Yes.
So in order to gain a stability, it completes its octet by one, first back bonding, and second dimerization. First is back bonding and the second is Dimerization, basically what is back bonding, I'm going to tell you. I'm going to explain it. Just first write it.
Done.
See how back bonding takes place and what is the condition for back bonding. So I'm going to explain it first, then we will write back bonding. So I'm going to take example of BF3. BF3. So you know that BF3 has a structure trigonal planar F3. And you know that boron is the central atom which has 6 electrons. In order to gain stability, there will be back bonding. There will be back bonding. And how does back bonding takes place and what is the condition? So the first condition for back bonding is one of the elements should, wait a minute, one of the elements should be from must be from second period element. One of the elements should be from second period element. So you can see both are second period element. Am I right or wrong? Boron and fluorine both are second period or not?
Yes.
So at least one atom should be from second period element, and the second condition is one of the elements should have lone pair electron and other element should have vacant orbital to get that lone pair. Are you getting my point? You can see boron configuration of boron will be 1s2 2s2 2p1, and you can see that in these three orbitals one electron is here and two electrons are basically two boxes are still left. And again for fluorine, if you are going to 1s2 2s2 2p5, there will be three lone pair. Of boron of fluorine will have three lone pair. So basically here is vacant orbital and fluorine is filled with, fluorine is with lone pair. So fluorine will donate electron to boron and there will be a double bond. There will be double bond like boron like this, and here I'm going to show it by dotted line. This is the basically the pi bond, fourth bond. Now it has four electron and it is not necessary that it is fixed for this. This bond will be moving continuously, sometimes from here, sometimes from here. Is that clear?
Yes.
So basically if I want to write it in resonating, just like resonating structure, you can see like this. This is the dotted line, fourth bond. Sometimes it will be like this, and it will be like this. So what is the condition? Basically the condition is one of the elements should be from second period element, one of the elements should have lone pair, and one of the elements should have vacant p or d orbital, so that's that element can gain electron. Just write it and then I will write about it.
Done.
Very good. So write with whatever I explained to you. I'm going to write it. Write with me. The special type of covalent bond in which this is basically partial double bond, partial pi bond. Is formed between vacant orbital of one bonded atom and filled orbital of another adjacent bonded atom of molecule is called back bonding. It's called back bonding. So basically, one of the atoms should have vacant p or d orbital, and one atom should have lone pair so that it can donate electron. Okay.
Done.
And here it will be lateral overlapping due to, just write it, lateral overlapping. Pi bond will be formed. Pi bond will be formed. Done.
Done.
Very good. Again, condition for back bonding. Condition for back bonding. First condition, one bonded atom should belongs to second period element, as I already told you. Second, one bonded atom should have lone pair electron. Third, one bonded atom should have vacant orbital, and vacant orbital generally it should be p or d orbital. Just write it and let me know.
Done.
Very good. Now see, BF3, you know that both the elements are from second period. This is mixing between second period element. So the back bonding will be very effective back bonding. It is a strong back bonding. When we talk about BCl3, boron is from second period, chlorine is from third period, and when it mix to form back bonding, it will be moderate back bonding. Moderate back bonding. So I'm going to write BB, back bonding. And when we talk about BBr3, it is from second period and fourth period. And by mixing, poor back bonding. Poor BB, poor back bonding. but there will be back bonding. And when we talk about Bi3, second period and fifth period, and when we mix it, very poor back bonding. Are you getting my point? So sometimes there will be question like effective back bonding in which of the following: 2p pi, 2p pi, B 2p pi, 3p pi. Basically this pi represents, it will form pi bond, 2p pi, 3d pi. So the effective bond will be from here, but all the three will form back bonding, but the effective is from second period and second period. Is that clear?
Yes.
Okay.
Done.
Very good. Trihalide of aluminium. Trihalide of aluminium, AlF3, will it form back bonding or not? AlCl3, will it form back bonding or not? AlBr3, will it form back bonding or not? And Ali3. So you have to tell me whether it is whether it will form back bonding or not.
First one will form.
First one will form. Basically, you just said 3p and 2p, right?
Yes.
Back bonding. Okay. Second one. What about the second one?
Both of them are not in second period, so
So it won't form no BB. And it is also 3p, 4p, so it is also not no BB. And here you can see 3p, 5p, no BB, no back bonding, right?
yes.
Here it will also no back bonding, because I already told you in the S block chapter that when first group, second group and aluminum forms compound with fluorine, it will be ionic bond. It will be ionic bond. Do you remember? So
Yes.
if there will be ionic bond, there will be no back bonding. Back bonding is possible in covalent compound, right? And since this is a ionic compound, so there will be no back bonding. Okay.
Okay.
Okay. Can I change the slide?
Yes.
Okay. Effect of back bonding. Effect of back bonding. You know that. Do you know that if I'm asking you that this is single bond, this is double bond, and this is triple bond, which bond will be lengthy?
Single bond.
Single bond will be lengthy, then the double bond, and then triple bond, right?
Yes.
The effect of back bonding in due to back bonding, write with me, due to BB stands for back bonding, bond length decreases. Why? Initially it was pure single bond, but due to the stability criteria, it forms partial pi bond that decreases its bond length, because it will have some partial double bond character, so it will decrease. Is this clear?
Yes.
Due to partial double bond character. Again, second point, due to back bonding, hybridization of central atom of molecule either changes or remains same. Either the due to back bonding, the hybridization will change, or either it will be same. Is that clear?
Yes.
So you can see that for no change, BF3, what is the hybridization in this, and what is the hybridization of central atom in this? That means you have to calculate the hybridization of central atom.
sp2.
sp2, here it will be sp2, right? And what is the hybridization of this?
sp3.
p2, because hybridization is equal to sigma bond plus lone pair. In both the molecules, there is no lone pair. So if you are going to calculate the hybridization, there is no lone pair, only 3 sigma bond, 4 sigma bond that represents sp3, 3 sigma bond, 2 sigma bond that represents sp. That means basically the sum of sigma bond and lone pair is 4, and then sp3. If the sum of lone pair and sigma bond is 3, then sp2, and like this. Okay. And you can see there is pi bond, so we don't need to calculate the pi bond. We don't need to count the pi bond. We just count sigma bond and lone pair. Okay.
Okay.
Okay. Can I change the slide?
Yes.
Now you will see. Tell me that here in this molecule, back bonding will take place or not.
It will take place in first one.
It will take place in first one.
First one.
And what about the second one?
It does not have lone pair, so it will not have.
It does not. It has lone pair. When carbon makes 3 bond, it will have a lone pair. So tell me again.
They will form back bonding.
This is from second period element, right? And this is also from second period element. This has lone pair. No doubt this has lone pair. But carbon already making 4 bonds. Does carbon have any vacant orbital?
No.
No vacant orbital. So there will be no BB, no back bonding. And the hybridization is sp3. Are you getting my point?
Yes.
There will be no back bonding because carbon doesn't have any vacant orbital. Now, this is also second period. This is third period element. Silicon is third period element. This has lone pair, but silicon, when you write the configuration of silicon, 1s2, 2s2, 2p6, 3s2, 3p6, sorry, 3s2, 3p2, and 3d will also be available. So it has vacant orbital, right? So it will have back bonding. And when back bonding will take place, before back bonding, I am going to show you before back bonding, this will have a hybridization sp3, but when back bonding will take place, this electron will come to form pi bond. And now when you count, there is no lone pair and sigma bond is 3, so the hybridization will be sp2. So it is clear that what I want to say is that for back bonding, it is not necessary that hybridization will change. It may change or may not change. You can see. Okay.
Okay. Done.
Very good. What is acid? In terms of Lewis, can you tell me what is acid? I already explained it. Did you get it? What is acid? Or should I explain it again?
Yes.
Trihalide of boron. Since trihalide is basically in central atom, it has 6 electrons. So for the stability, the trihalide of boron or trihalide of 13 will have some more electron by withdrawing, are deficient, are electron deficient compound. Therefore, they are Lewis acid. Lewis acid is one which needs or withdraw electron. So is there any doubt regarding Lewis acid?
No.
Yes or no?
No.
Okay. So here is BF3, BCl3, BBr3, BI3. Can you arrange it in decreasing order of acidic character?
Can you do this?
Yes. You know, effective back bonding will be in BF3. So it won't require any other electron, right?
Yes.
Because the back bonding here is very effective and it is stable. Down the group, when we will go down the group from fluorine to iodine, the effective back bonding will be decreasing because there will be poor and very poor back bonding. That means boron will not satisfy because of back bonding, because of very poor back bonding. So in acidic character, you can understand that easily by, if this is not satisfied by back bonding, that means it is not stable. So most acidic will be Bi3, then BBr3, and then BCl3, then BF3. This will be least basic because it has effective back bonding, and in back bonding it is stable. It is stable. Okay.
Okay. Done.
Very good. Wait a minute. So I'm going to write this its reason as back bonding tendency decreases electron deficiency, electron deficient tendency increases, decreases. So acidic character decreases. So in short, back bonding tendency decreases, back bonding tendency increases, just correct it. Back bonding tendency increases, electron deficient tendency decreases, and acidic character decreases. That's why BF3 is less acidic. And we can write BF3 is less acidic than Bi3 because the back donation of electron from a small size fluorine to boron is more than back donation of electron from iodine to boron due to larger size of iodine. Please write it and let me know if you have any doubt regarding this.
Done.
Wait a minute. Are you done with all this?
Yes.
Very good. Now write topic. Not a topic. Not a topic. Write a note. The BF bond length in BF3 is 130 picometer and in BF4 minus it is 143 picometer. Why it is so? Because in BF3 there will be partial double bond character due to back bonding in BF3, partial double bond character. So bond length decreases. But in BF4 minus, this is pure single bond. Pure single bond. That's why it is greater than BF3.
Done.
Very good. Now we will have some elements does not form, some compounds does not form back bonding because of its condition. So there will be dimerization, or you can say bridge bond. So going to discuss about bridge bond. What is bridge bond? So write with me its definition. When surrounding atoms of monomer is joined to two or more central atom, to two or more than two central atom, the bond formed is called bridge bond. I will explain it. First, right.
Done.
Very good. Now, there will be two type of bridge bonding. Basically, one is known as X greater than Y, and wait a minute, X greater than Y, and you can see X, wait a minute, first we are going to take X less than Y and X greater than Y. What is X and what is Y? So basically here X represents number of atom. If number of atom is less than number of central atom, number of atom, and here is number of electron. Basically X representing number of atom and Y representing number of electron. If number of atom is less than number of electron, then there will be bridge bonding. Not bridge bonding, there will be I will just tell you. And X greater than Y, that means electron deficient. Just see what I want to say. Electron deficient molecule, electron deficient molecule. Wait a minute. So here is bridge bonding, X less than Y and X greater than Y. Now we can see X is number of atoms and Y is number of electron, and Y is greater than X, that represent electron rich bonding, electron rich bonding, because electron is greater than number of atom. And here you can see number of atom is less and number of electron, number of atom is greater than number of atom, the number of electron. That means electron deficient, electron deficient bonding. And whenever there will be electron deficient bonding, that is called banana bonding. That is called banana bonding. Is that clear?
Yes.
Just write it.
Done.
Very good. Now see what is banana bonding and how it will form. What is dimerization? So just see AlCl3. First check it whether it will form back bonding or not. Will it form back bonding? Akifah?
No.
No back bonding because 3 PT third period element, so it will not form no back bonding. So since it has also 6 electron, in order to get a stability, it will dimerize and it will be like AlCl3 whole twice, so it will be Al2Cl6, Al2Cl6. And how the compound forms, just see aluminum, chlorine, chlorine, and one of the chlorine, and here aluminum, chlorine, chlorine, and chlorine. And now since chlorine has lone pair and aluminum has vacant 3d orbital, so it will give its electron and form coordinate bond. In the same way, it will also give its electron. Now you will see that this will have sp2 hybridization, but this will have sp3 hybridization. Now you can count aluminum is forming 4 bond, so it will have 8 electrons in its outermost shell, so it is stable. And now the main question is that this is the central atom. How many central atoms it is? Three.
Hmm.
Three atoms. And how many bond between these 3 atoms are? How many bond between these 3 atoms are?
6.
6. So basically you can see atoms are oh, sorry, not 6 atoms. How many electrons it is?
12.
6 electrons, right? Now you can see atoms are lesser than number of electrons, so dimerization will take place. Dimerization, here it is dimerization, and it is also known as how many electrons does it have? Sorry, I just, how many atoms does it have? 3. And how many bonds it is forming between these 3 elements? 3 bond, sorry, 2 bonds.
Yes.
So then how many electrons it will be? 4 electrons.
4.
So it is known as 3-centered 4 electron. 3-centered 4 electron. Okay.
Okay.
Just write it. Three-centered 4 electron. It is also an electron rich bonding. Are you done with this?
Done.
Very good. Now see what type of questions examiners can ask. These 3 atoms from this side and these 3 atoms from this side are in same plane. 6 atoms are on the same plane, and this 2, one will be outside of the plane and one will be the inside of plane. So I can write two chlorine atoms are out of plane, above plane, above and below plane. Just write it.
Done.
Very good. Now going to write some points regarding this. AlCl3 dimerizes, but BCl3 do not dimerizes. Why? Is due to following reason. We're holding for a minute. Okay, Azam is just right. So Akifah, uh, since am I audible?
Yes.
So AlCl3 dimerizes, but BCl3 do not dimerizes due to following reason. First is due to effective back bonding in BCl3, and the second is if BCl3 will form, if BCl3 will dimerize, then since the size of boron is small and the size of chlorine is large, so there will be steric hindrance between chlorine boron. That's why it will be unstable. So BCl3 do back bonding, not it doesn't dimerize. You got it?
Yes.
Okay. Can I change the slide?
Yes.
Now see, halide of aluminium, and here dimerization, that is dimerization. You can see AlF3, will it dimerize AlCl3, AlBr3, AlI3? Will AlF3 dimerize or not? Yes or no?
Yes.
No, because it is ionic compound. It is ionic compound, and ionic compound do not dimerize. They have bond, ionic bond. And AlCl3, Al2Cl6, Al2Br6, Al2I6. This will dimerize and form 3-centered 4 electron. Okay.
Okay.
Just write it and let me know.
Done.
Very good. Now, we will talk about halide of beryllium from first group, S block. Basically, here it is beryllium difluoride. Beryllium fluoride, and here it is also fluoride. It will form back bonding due to effective back bonding. There will be back bonding. Because it is also second period, it is also second period. And here you can see 1s2, 2s2, and all the 2p orbitals are vacant, so it will form back bond. Just write it.
Done.
Very good. Now we will talk about a structure of BeCl2. In different phase, it exists in different structure. A structure of BeCl2. First, gas phase, BeCl2 exists as monomer. And what is the hybridization of beryllium? Tell me. And in solid phase, it exists in polymer as well as dimer. It dimerizes. Just write it and let me know.
Done.
Very good. Now, when we talk about dimerization and polymerization, how it happens? See, beryllium, chlorine, and chlorine. Beryllium, chlorine, and chlorine. Now you can see chlorine has lone pair electron, and beryllium has vacant d orbital. So 2 moles of beryllium chloride will dimerize and it will form Be to Cl4. This is called basically dimerization. What about polymerization? Polymerization, that means number of molecules are very much too large, like Be and then Cl, then Cl, then Be, then Cl, then Cl. Again, you can see Be, Cl, Cl. And again, you can see this will donate it in the same way, this will donate it in the same way, there will be both this will donate it, and it will be like this, it will repeat it, it will be repeated again and again. So it will be polymer form and this will be dimer form. Please write it.
Done.
Very good. Now we come to know about banana bonding. Banana bonding. Basically, this is bonding in boron, bonding in diboron. BH3. This is basically electron deficient. Electron deficient compound, since you can see it has only 3 bonds, so it will have 6 electrons. So it is electron deficient bond, and it converted. This is basically boron, and it converts into diboron. Dimerizes. It dimerizes itself and converted into B2H6. This is known as diboron. Just write it, and then I will show you how banana bond formation takes place.
Done.
Very good. Now, how it forms, banana bond formation takes place. Basically, this is BH3 and this is BH3. You can see hydrogen has only one electron. It doesn't have any vacant orbital and any electron. And boron also have no electron free, no lone pair present. So what happens here is basically this one bond momentarily moving between these two and these two. This one bond, do you know resonance?
Yes.
So in resonance, you can see like this bond will move to this bond will move to this. In the same way, this single bond will move to this, and this momentarily it will change its position, and again in the same way this will move to this and this will move to this point. Now you can see there is three centered, and in between these three atoms, in between these three atoms, only one bond is here present. Only one bond is present here. Are you getting my point?
Yes.
And this bond is moving left right left right left right, so one bond has two electrons. So basically this is three center two electron, and whenever there is electron deficient compound, you can see atoms are greater than electron, that means banana bond will take place. Okay.
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 Done.
Very good. Is there any doubt?
No.
Okay. Now we will start group 14 elements, also known as carbon family. Okay. Now you can see carbon, silicon, germanium, tin, and lead. Here it is. It's 32, 50, 32, and then 14, and then 6. What we do here, add 8, then 18, then 18, and then 32 in p block elements. Configuration: helium 2s2 2p2, neon 3s2 3p2, argon 3d10, 4s2 4p2, krypton 4d10, 5s2 5p2, lead, xenon 4f14, 5d10, 6s2 6p2. Just write it and let me know.
Done.
Very good. Now we will talk about its oxidation state. When we talk about oxidation state, group 14 elements shows +4 oxidation state. +4 oxidation state due to NS2 NP2 configuration. It also shows down the group, it also shows +2 oxidation state due to inert pair effect, due to inert pair effect. So down the group, +2 oxidation state is more stable than +4 oxidation state. So if I'm going to write order of stability of +2 oxidation state, so down the group it is increasing. So lead, then tin, then germanium, then silicon, and then carbon. When we talk about ionization energy, so down the group ionization energy increases because size increases and Down the group, ionization energy decreases because size increases, so electron can easily come out. Okay, basically due to poor shielding effect, we can also write due to poor shielding effect of 4F subshell. Z effective increases, ionization energy increases. Wait a minute. There will be slightly lead and then so basically ionization energy of lead is greater than 10 because of poor shielding effect. Z effective increases, size decreases, ionization energy increases.
Done.
Very good. Now, talking about density. Down the group, density increases. So if we talk about carbon, silicon, germanium, tin, and lead. So here, if you are taking carbon in the form of diamond, then the carbon will have more density than silicon. Carbon will have more density than silicon, and then germanium, and then tin, and then lead. Again, carbon, if it is in graphite form, it will have less density than silicon, then germanium, then tin, then lead. And if we will talk about boiling point, boiling point of carbon is greater than silicon, then germanium, then tin, then lead. In next class, it will be completed.
Done.
Very good. After density, we will talk about allotropes of carbon. When we talk about allotropes of carbon, two form of allotropes of carbon. One is crystalline and another is amorphous. Amorphous allotropes of carbon is divided into three part: coke, charcoal, and lamp black. And crystalline is also divided into three parts. That is graphite, diamond, and fullerene. Now you can see we have to discuss all these three. These three are very important. Just write and let me know if you're done with this. We just need to discuss the structure, hybridization, geometry of graphite, diamond, and fullerene.
Done.
Very good. Now write topic graphite. Graphite. Write with me. It has layer type structure and contains 2D hexagonal layer type. 2D hexagonal layer type. Second point you can write. Layer of graphite are held by weak van der Waals force of attraction. The third point is the distance between two layers in graphite is 340 picometer. In graphite, each carbon is sp2 hybridized. Each carbon is sp2 hybridized and forms 3 sigma bond with 3 neighboring carbon atoms. And you know that carbon has 4 electrons. One of the electron here is free. That's why it conducts electron. Fourth electron forms pi bond and it delocalize. Basically it moves like in resonance. It delocalized over the sheet. With the help of this it conduct electricity. Okay.
Yes.
And next point you can write the CC bond distance in graphite is 141.5 picometer. Okay. And one of the most important point here I'm going to write why it is slippery and why it is used in machinery running at high temperature, since, write with me, two layers of hexagonal are held by weak van der Waals force, due to which one layer can slide over other layer or another layer. Therefore, it is slippery, soft or slippery. So basically, due one layer slide over other layer. That's why it is slippery or and soft. Due to this reason, graphite is used as lubricant in machine running at high temperature. If you will use other oils or liquids in place of graphite, that liquid will evaporate. That's why graphite is preferred. And we can also write, but oil cannot be used because it will evaporate at high temperature. So basically, if you are going to write its structure, it is like this. Wait a You can see this is making three bonds, one, two, three, and one of the electron is free, so it will delocalize to form pi bond in this way.
Done.
Very good. Now we will talk about diamond. At what time you will be free on Saturday?
Same time.
Each carbon is sp3 hybridized. All the four electrons are making bond, sigma bond. In this structure, directional covalent bonds are present throughout the lattice. Therefore, it is hardest substance. Another point, diamond has covalent bond but still has very high melting point and boiling point BP due to 3D network structure. It is used for manufacture of tungsten filament in electric light bulb. Just write it and let me know.
Done.
Very good. Now moving to the next, fullerene. So Akifah, we will complete this chapter in next fullerene, and then this chapter is very less syllabus left according to the deleted syllabus, and it will
Okay.
be completed. And next chapter we will start like equilibrium first. Okay.
Okay.
Do you have any doubt?
No.
Oh, thank you.
Mm.
Hmm.